this on? There you go.
Okay, so our final speaker of the day has a lesson from, I think, personal experience to share with us. And that's, this is a really good thing. It's how to build an interoperability lab, make sure things are going to work. You know, we've had some speakers earlier today that were talking about test, test, test. And this is a way to do it. So, Alan and Charlie, looking forward to hearing what you guys have to say. Thank you.
Thank you, Wes. Thanks for the introduction. So, as you said, my name is Alan Wollenstein. I'm with the NFL Network, also known as the NFL Media. I'm the senior manager. Basically, my whole responsibility is the Interoperability Lab, bringing all new technology, testing it out, moving on. Charlie helps me with it. He's my hands-on. While I'm talking to vendors and getting things logistically going on, Charlie's in there getting his hands dirty. That's Charley Haggarty. And this is us undertaking an interoperability lab. So obviously I wanted to start with what the procedure we took. First we start with the goals. What did we want to do? How we prepare and what we learned from this testing. Goals. What should we build? We break things. We will break your gear. That's basically what we told every single vendor. It's going to come in, we're going to break it, expect it. The goals. First, we wanted to learn about CMT standard 2110. How is it disruptive? What's new? What has changed? What are the standards? What we needed to generate to test it, right? Because you just don't walk in and go, okay, here it is, let's do it. We need to figure out, okay, what is 2110? How many flows do we need? What kind of flows do we need? What is 2110 broadcast facility? How do the workflows look, right? Because now we are breaking essences, right? So we now have audio and video and ancillary separate. It's not something that just goes on one baseband signal. How do we troubleshoot that? That's been a big question that we've been trying to figure out for a long time. And what do we need to look for? So how do we, in the old baseband days, when you saw an artifact and you had an idea, oh, might be the timing, it might be this, it might be that. What kind of artifacting will we see? Do we see frame drops? Do we see artifacting? Do we see slowdowns? What kind of things do we see? And that's what we were looking for. And of course, because we are trying to build a new facility, we are looking for the best of breed. What kind of products? How do they compare with each other? And how do the vendors interoperate? Right? We wanted to see how they actually interpreted the standards and the specifications and work with them. So what did we do to prepare and do all this? What it took to build the lab, how we went about breaking it. First, we had to educate ourselves. Then we had to select the gear that we were going to use, and then we also created documentation, not only of what we were doing, but how we were doing it. So education, obviously, we first had to learn about the topic, the standard itself. We've been going to conferences, documentation, talking to experts, coming to showcases like these and learning from those. Learn about all the protocols that exist, right? Because it's not just 2110, it's 2110-10, -20, -30, -31, and there's now all additional on top of that, as well as you have the NMOS specifications for the communication protocol, but you also now have third parties that have their own protocols, and how do those interact? Tools. We needed tools to do this and learn about those tools. How do we generate the content? Again, really important, being able to generate that content and push it out. How to introduce impairments. We wanted to be able to affect it, to have some issue on it, so we could look for those symptoms, so we could recognize the issues that we were looking for, so we could, once we implement the live production, we could say, oh, whenever you see that shift to the left, that probably means something happened on this system when you did that. And measure as well, because we wanted to compare the systems, so we had to measure how they compared against each other. We did research, as I already mentioned, documents, conferences, videos, and talking to experts, and of course, hands-on. We got our hands on as much of this stuff as we can. When somebody brought in the demo, they showed it to us. There we are inside the rack case going, okay, hold on, what happens here? For the selection, we had to select the tools, like I already mentioned, how to generate, how to measure, and what we were going to look, what kind of configuration we we're going to set up, what were we actually looking for, the objectives, what are we measuring? Because there's some measurements that are pointless, but there's some measurements that really matter, and you want to get into those. The infrastructure, where are we going to locate it, how are we going to locate it, and the inventory. Again, tools, really important. What are we going to test as well? Are we testing FPGAs, processing modules, IPGs, IP gateways, or are we just going to test monitoring systems? What are we testing? We had to select what you needed to test. So the first part that we decided to do in that selection was the formats. You obviously have choices between 1080i, 1080p, 4K. Are we going to test SDR, HDR? How many stream counts? How many channels per stream? These were questions that popped up as we were learning about the gear. And we decided internally, because of our current setup, to do 1080i with 2 streams of audio with 8 channels each. That's our current workflow, and that's how we decided, but it was after research and decision that this is how we're going to move on from this point on. Protocols, like I mentioned, there's multiple protocols. You have NMOS, Amber Plus, APIs, and other drivers. And then there's what we've been discussing, IGMP joins, right? There's a lot of, how do you do the routing? And a lot of people are saying you do a static multicast routing using a software-defined network, or you can do a dynamic multicast routing where you just let the end node say, I want to join that, and see what happens. We actually are testing both. We've been testing both solutions. We started mostly with the simple joins, let the system do it and see what happens. Then we brought in SDNs and see how those work. We went back to the systems joining because we actually did something really interesting. We had 2 networks. We had the -7, the heatless merge, that everybody calls red or blue, green or blue. We went and called it amber and blue, just for the fun of it. And the amber and blue, the reason we call it amber and blue is really simple. Everybody keeps referring to them as A and B. Amber, A, blue, B. That made it a little bit easier for us to remember that if you just write A, that's the amber, B is blue. Our amber was one vendor, and our blue was another vendor. So that gave us an opportunity to bring one of the 2 using -7 and still get measurements against each other. But we also found out that we needed to be in band and out of band, so we've tested all combinations of those protocols as well. The network, here we go, talking about there's multiple topologies that you can use. You can have the star topology or core, where you have 1 switch in the middle and multiples on the edges. You can have a single switch or monolithic, or most people are now starting to call spline. Or you can do a spine leaf. And we realized that there were going to be more than just the 2110 network. There's the management network, there's the management control, audio, intercom, and the PTP. We know that the PTP has to be within the media, but there's also things that we tested to get those to work together. So we ended up with basically 3 networks. The amber blue, as we mentioned, for the -7, using 2 manufacturers, and a 3rd network where we did the control, the audio, the intercom, and the PTP distribution. That's where we fed the grandmasters, and then that became a leaf to the spines on the amber and blue to fit the rest, and that way we would know that we were feeding the same PTP on both networks. Cables. Obviously, you have to discuss, are we going to do single mode, multi-mode, active, passive? We ended up with a bunch of different versions because each vendor has their own requirements. Other vendors don't care. We prefer, if we could, single mode, but cost prohibited and vendor provided their own sometimes. Data gathering. So this is the objectives. This is what we were looking for. And we realized that we had 2 classifications. We had the tangible and we had the intangible. The tangible was the outcome introduced. The tangible was literally the things that we could measure or see on screen. So that's where we were measuring if there was jitter, if there was how long it took to do a delay processing from point A to point B, and how each vendor reacted. We also introduced, in this case, like the zebra pattern. We got tools to introduce impairments, right? So zebra pattern, drop packets, jitter, delay, and we saw how the video reacted to these issues. We also looked at the performance, obviously how fast they would react, how quickly they would reboot, how all these little things that we could measure with a clock or through a monitor or waveform monitor, anything that we could measure was under the tangible. Then there was the intangible. That is, how quickly did we get to set it up? What it needed to be set up, could we do it ourselves? Did we need help from the vendor? All that came together for us to see if we could do it, because one of the things at the NFL Network that we do is we provide our first, and if we can, second tier support. So that was one of the reasons why we decided to measure those things, because we need to know, can we support it ourselves? Since we're a 24/7 operation, we need to be able to react quickly, and only in extreme case do we need to call support and wait on them, right? So again, on our goals or objectives, what subjects were we going to test? Processing processing nodes, the FPGAs, whatever you want to call them. They have 100 names now. They do 100 different things. The production switchers versus the network switches. We use COTS to test versus other solutions, cameras and CCUs, intercom, audio system, phone system, multi-viewers, broadcast controller, SDNs, orchestration, monitoring, and PTP grandmasters. These are the things that we wanted to test, compare, and see what we consider the best of breed for us based on the previous infrastructure. Going back to that, the facility. We had to pick a facility, right, a location within the facility that we could have racks and space, workstations and panels and consoles come in, so we could set them up, test them out, and see how they worked. We had to figure out if it's going to be isolated or how many people are we going to allow in. Is it physically isolated versus also logically? Logically, in this case, meaning is it part of our live production network and other people can jump on it, or do we need introduce a VPN and only certain people had access to that private network? So we would control the access and just have the right people test around. And again, cables, really important. You don't think about it, but it's a lot of budget, it's a lot of money. Even those vendors will provide their own. We still needed to have some because some didn't provide their own. So you had to have single mode, multi-mode, and patches. And I'll get a little bit more into why we need patch space for the lab, right? Inventory. So this is stuff that we definitely needed to have to do the testing that we did. We needed measurements, scopes, waveforms, obviously, an AV timing system, so we could see the delays introduced to the audio versus the video. Network packets, now we're measuring also the packets. IP gateways for encapsulation and decapsulation, because a lot of the sources we had available were still baseband. Servers, we have bare metal and virtual machines. So as you guys just heard the Telos guy talking about VMs, we have a couple of VMs that we are using for certain things, and we have a couple of systems that are still not certified or validated for virtual machines, so we have bare metal to put it in. As well as, again, panels and DAs to generate more content and try to get closer to the scale that we were trying to reach. Connectivity. So we have the switches. These are the network switches for the media and the audio, for the management. And one thing that we learned, PoE, really important. A lot of devices need it, as well as the adapters and cables, because you'll have QSFP versus SFP plus versus all these single mode versus multi-mode. Generation. So this is really important. PTP. Everybody talks about it. If you don't have the right PTP setup, the whole lab is going to go down. There's no point on doing it if you don't have a PTP. Video and audio signals, obviously what you want to test, bar, tones, ABC in sync, footage that you can play back and watch and see what happens. A network emulator and impairment. That's the one that would introduce, you feed it in what you want, introduce the impairments, and create a new stream with those issues, right? And obviously the playback and record devices, because we wanted to record and then play it back and see frame by frame if there were issues introduced. Software. Surprisingly, you think, oh, well, it's all like with this whole thing. We ended up discovering that we did need a bunch of software that we also wanted to test, not only for our purpose, but for us to be able to work with this. So first, the broadcast controller, simplify the process, as well as be able to measure how long would it take to take a shot, to create a route. The scope and waveform monitors, because you have your physical versions, but now there's software versions as well. And some are pretty good, and we were pretty impressed with what we achieved with those. Multi-viewers, we've seen a lot of software based now, as well as layout design for the multi-viewers. Right? You want to set those up, change them, let the broadcast controller change them. Network orchestration, we needed to monitor, configure, and control the switches. And we discovered that not everybody does it the same way, but we needed to be able to measure that as well. That way, monitoring, we could see if we were getting the joints or not, how we were getting those joints, how long it would take, as well as how we had the switches configured. Are we using IGMP version 2 versus IGMP version 3? And node orchestration, that's what I'm calling the FPGAs, the processing modules, the IPGs, need to be configured. Are we doing 1080? Are we doing 4K? That's where that orchestration came in. A virtual machine cluster, obviously, for the VMs that we were using. Container host, like they were talking, you can have Kubernetes or Docker, and a bunch of these new products that we're looking at come as a container. So we needed to have a container host that we could run them on, as well as a DNS server, for example, with the NMOS registry. If we didn't have that, then we couldn't test the NMOS registry and test the capabilities of NMOS, especially ISO 4 and 5. Documentation. So these are the documents that we created for this testing. First, we created the procedures. What are we going to measure? What are we going to capture for what kind of capture behavior? The timing, again, pretty repetitive. Auto shuffling. We also generated drawings, topology, elevation, and flow diagrams, as well as spreadsheets with the IP addresses. Everybody keeps talking about tracking or not. It's a lab, so it's smaller, so we can get away with it. But there's another reason why we did have it, and I'll explain a little bit later. Multicast groups, we actually also did static multicast groups. And obviously, where are we going to record the results? In some spreadsheets, that's where we did it. And a really important note I want to make is the common repository to share the information and findings. It's good to know because you have more than one person working on these. You want all of them to have access. You want everybody to be able to see this. Lessons. What the lab taught us. What we thought ourselves breaking. What broke that we didn't expect to break. That's really what it comes down to, right? This is where all this preparation and all these goals, you still don't prepare for everything. And this is what we learned from that. Part 1, learning the basics. Just going to 2110, to going and learning about 2110 wasn't enough. Going and learning about the switches wasn't enough. We actually had to get a primer on routing and multicast, right? Because you have the IGMP, what's PIM, what's sparse mode, what's other modes are there. Which one are you going to use? Why would you use one versus the other? What's a rendezvous point? Routing. There's right now BGP, OSPF. What's the differences? Which one is better? Why is it better? Do you need it? No, you don't. Streaming media. Understanding the actual media. This is a standard that has existed and been used by IT, but there's a lot of confusion, like payload IDs. There are payload IDs that already exist, and they're being used versus the payload IDs that we're using for 2110 that are customizable, and every company can use them different, and you have to watch out for those things. We've had issues with some, as well as what is an SDP file, right? The session description protocol file, learn about that. How is it formatted? What's the content of it? And I think that's a really important one to learn. As well, again, I cannot emphasize PTP, profile and accuracy dependencies. How does that affect? Which is the order? If you set the most PTP grandmasters will have two priorities, but it'll actually go first to priority 1 and then go through another list of accuracy and selection before it hits priority 2 and makes a decision, right? As well as one of the biggest things that we discovered as we were testing and we had issues, a lot of the answers that we got from support was, how's your GPS? You can definitely run it free run, but that's something that we got back is, how's your GPS hooked up? And we didn't start with free GPS. So that introduced a lot of interesting conversations on how to go about making sure we're in sync. Having a schedule, that's another lesson learned. Having a schedule, not like I mentioned earlier, I was doing a lot of the logistics, and it was good to have a schedule so I could actually tell the vendors, you can come in this date or that date, and sometimes you have two vendors coming at the same time. You want to make sure that they're not competition and they start trashing each other in your own lab. It also allowed us, because we did it in stages. First test the FPGAs, then test the SDNs, so we could schedule what changes do we want to do between those, which FPGAs are we going to use. Also considering the training, and one thing to consider when you're doing the scheduling is when they come in and set it up, how long is it going to take to set up, how long is it going to take to train you on the product, because they're going to help you do the first initial test, but then you're going to run for a while with them by yourself. And that's how long is that loan? Most of this gear is loaned, and how long are they going to allow us to keep it and test it, right? You can plan for, like I mentioned, you can also plan, okay, are we borrowing FPGAs from one company? How long can we keep those in and test them against the SDN by somebody else, the NMOS by somebody else? So planning for that overlap so you can test them together. Now, obviously be flexible, because first time you do a test, it takes you 2 hours, but the next time it might take you 5 minutes. But with a vendor, it might take you 3 hours. So testing is not always indicative of the consecutive tests, right? Second part of the lessons, owning and understanding the environment. That was a key element. We understood every single thing that went into this environment. Especially going back to the PTP, for example. Testing procedures are not only as good as you understand, and some tests were not ascertaining what we expected. We were doing failover of the PTP, and we were seeing issues on the decapsulators. And later on, we found out that it was the lack of GPS, which gave a less accuracy to our PTP masters, which was in turn in reaction of the switches that were having issues. It wasn't the PTP master, it wasn't the decapsulator, it was the switches that were having issues. And I can let Charlie go into a little bit more detail on that if you guys want to hear about that lesson learned. He definitely got his hands dirty, and we're still learning about it a lot. Being able to do quick changes. That's another reason, owning the environment, understanding it well, as saying somebody comes in and says, well, we don't do 1080i, we only do 1080p. Knowing what it takes to do that switch just to test that product, right? Again, account for how the setup affects the results. Knowing what we set up, how we set it up, we knew that, well, we can't really test an SDN proper with a heatless merge right now because we're using two vendors, and trying to get one SDN to control both is not an easy solution. Really important though, even though we owned it and understanding, having a strong support from the manufacturer, from the vendor, was a really key element. Being able to quickly call them up and say, okay, we did all these, what's the next step to troubleshoot the issues we're seeing? I'm a big fan of this next lesson, enforcing the documentation. I'm a huge fan, because it does make it easier to be able to track changes, not only to the lab, but to the procedures. And being able to track those changes allowed us to know, well, we tested the same product 3 times, but now we know what changes happen in each version, so we know what we changed, how it changed, and now we can see the actual measurable changes. As well, and this is the biggest kind of funny, quickly provide any information to all parties involved with the assessment. So when a vendor came out and said, what are you guys testing? I could just point them to the documents and say, here's the procedure, here are the drawings. They could say, oh yeah, we've done that test, no we haven't, oh we're gonna do that test as well, and we can then compare with the manufacturer their results and our results. Part 3, space allocation. This is going back to the facilities. A quiet space. Most of this gear is loud, you'll put it in racks, but you still want to test for audio, intercom, telephone system. So having a quiet space where you can sit down and listen to these is really key. As well as having the space to have the production switcher and audio console sit down and test them and look at how they do their internal switching when you route into them and then route out of them, right? Panels and displays. Obviously, we were testing panels, and you want to have displays where you can see how the routings are being done, how you're reacting. Patches, going back to that. Having patches of fiber and copper, being able to have the signals going in and out of the machine room, the data center, and the location where you're sitting and doing all this work. Do not assume that there's only going to be rack mountable gear. They will bring rolling cases. I do want to mention that when we started, we only had 3 racks in the lab. Currently, we have 8 racks, and we have 4 rolling cases in the lab sitting around. That is almost 3 times as much as we planned for. Also planned space. We've had large or multiple groups of manufacturers and people in the lab. At one point we had 12? Yeah, 12 people. Our lab is small, and we ended up with 12 people in one tiny lab trying to get all these things going, and it was between the NFL and 2 vendors. Reality of scale. So the NFL network is a really big, even though it's a small network, we handle a lot of videos and footage. I mean, if you think about it, it is Sunday, right? How many games are going on right now? How many cameras are in each game? And we try to handle as many of those as we can. So we have a really big scale for a small amount of channels that we deal with. So the desire for us to capture that scale, it was becoming an expensive task. And the sample size, the scale that we did achieve, did not cover all the possible concerns that we had. For example, CPU loads. How can we load a switch CPU to replicate if we had thousands of flows? And that was one of the concerns. So we just had to accept that there will be limitations in the lab unless you put a lot of money. Which brings us to the next point. The last but not least, actually the most important, have a really big budget. Surprisingly, if you do want to do the scale properly, that budget is going to be big. But we were surprised on how much we did add on top of all this stuff. And I am on the last slide, and I did use most of my time. Okay, perfect. We started thinking that we were only going to need a couple of switches, a waveform monitor, a couple of IP gateways, and some software. We ended up adding a bunch of software. That's where we end up with VMs. We ended up with bare metal servers. We added other IPGs, so IP gateways or FPGAs, because we wanted to compare and see how they work together, as well as the signal and impairment generator, which was something that we did not think at the beginning, and we ended up adding. And that can build up. A good impairment generator can be expensive. It's a good tool. It's worth the money, but it is expensive. On that note, some of the gear that we did start did not end up staying in the lab. We did not end up using it. One, because of lack of features, and they were taking a long time. They weren't compatible with the standards, or they weren't doing the standard at all. Changes either in operation or product line itself. Some companies, as we tested, changed their path. They were going in one direction, then they went to another direction, then that we weren't comfortable. Like they say, don't change a horse in midstream. Manufacturer approach was not aligning with ours. So that's a bit of a personal for us. We have a certain vision of where we want to go, and when a company says we're going in one direction, and we are saying, sorry, that's not the way we're going. So a lot of not a lot of companies, but some of the products simply lost out at that point. But something we did learn a positive, and this is the long run. We originally the lab started as, let's set up for a new build out that we're going to be doing in the next couple of years. But we also learned that there's going to be more that we can get out of it. It's a great training resource for the staff. So now we can bring our own staff, help them learn the new products, how to control the environment, how to recognize issues, how to quickly repair it. And because it's our own environment, we can roll back and bring it back to a working status functional without interrupting production. We can keep testing for new products as they get updated or as the new gear comes around and we're curious, does it work? How does it work? Let's bring it in and test it. And also it allows us to see the market trends. If something changes, NMOS ISO 08 is being tested. Is it going to be something that we want to look at? How is it working? Bring it in, test it out. So we're allowed to evolve as changes happen and test them and decide, do we want to apply it, how we want to apply it, and then push it out to the live. Just quickly, just for references, if you guys were wondering, obviously the NFL Network is a California-based, provided live and pre-recorded sports programming for the NFL media worldwide. I have about 20 years experience in both IT and broadcast media, both as a vendor and a customer. Charley has been 10 years doing primarily in sports, in broadcast and IT as well. And obviously my boss, Bruce Goldfeather, VP of Broadcast Engineering, who was basically a financial backer. Thank you.
Okay.
So
I was going to say, Charley, did you want to say anything, or are you?
Well, I could help field any questions if anybody has any questions.
So, do we have any questions? I do have one question. I was interested.
Yeah.
So this looks, this is a pretty big investment, pretty big commitment.
Right.
Had you ever done this kind of a lab before for other technologies, or did you just decide, boy, we really got to do this for IP?
I have done labs before as a vendor.
Uh-huh.
I did a lab mostly for IT stuff, not for the IP, where I would test the new gear as it came in. So I do have experience doing labs. Luckily, as a vendor, we get a lot of demo gear, and that's where we do that testing, and then we can tell the customers, this is what we learned, this is what we tested, this is what we look for. So that's been my experience with labs, but this was a major undertaking because this is completely new technology, with new concepts, and I've seen other companies that done similar stuff, but not in the broadcast side, mostly on the IT side. So it's bringing those IT ideas into the broadcast engineering.
And when did you start this?
2 years ago, approximately. I joined the NFL about 1.5 years ago, and I took lead and been carrying it for about 1.5 years now.
And is it going to keep going?
Yes, definitely. I mean, after this show, we're going back and we're going to hit again the SDNs. We're going to be hitting the broadcast controllers again. We've done a lot of the physical hardware. Now we're going to do a lot of the software and workflow testing.
Yeah, right here.
My boss.
In conjunction to this, we have somebody that's just doing a POC on storage, new technology, NVMe storage, and also VDI technologies on how to client-facing systems, editing and graphics, so that how we spin them up, put them up in the cloud, and how we work together. So now we are ingesting on the 2110 network, streaming right to disk, editing it on virtual machines, and then publishing it and using it. So there's other parts to this whole operation that are going on at the same time.
Yeah, and that's part of those 12 racks that we mentioned. 6 are basically the broadcast, 6 of them are the storage and VDI solutions. We talked to IT regulars. That was an interesting conversation that we've been having because we're still looking at it as a broadcast VDI kind of situation where we're trying to see if we can introduce editorial and graphics, which have always had a hardware requirement with the I/O cards and the in general. So there's been an interesting conversation with some of these vendors.
Yeah. So and then next thing is a big pipe to the cloud, right?
Yeah.
All right. Any other questions? Yeah. Right.
Excluding Wireshark, what are the top 3 bits of test equipment we need?
With excluding Wireshark, we used Tektronix Prism. We also used Smart Scope from Lawo. And a third one. What's a third one
We
that I?
use Smart Dash as well.
The Smart Dash, but
Similar.
How about the impairment generator?
impairment generator, we use Packet Storm. We got the new version, the 8XG, and as well as the Packet Storm VIP. Those are, so 2 additional there.
The EBU list website is a very helpful tool as well for capturing packet data and importing it to see how it matches up with the 2110
Right.
specification.
As well as the switch provided monitoring tools were also a good way to go about it as well.
S-Flow, is that?
Yeah, part of it is flow, part, yeah.
Okay.
Depending on a lot of telemetry, right?
Gotcha. Anybody else? Yep.
I was just curious, you've been doing this for, 2 years, year and a half, 2 years. How have things changed in the industry over those 2 years? How has acceptance been gained? Linear, exponential? How has that gone?
That's going back to that market trends, right? So we've seen earlier, we saw a lot of Amber Plus adoption. Now we're seeing more NMOS adoption. So that's one of the things that we changed, but we're still seeing a lot of mixed results on that. For example, we've seen a lot of changes on some switch companies. We started with 3 switch manufacturers, now we're down to 2 because one of them kind of dropped the ball and walked away. They still want to, but they're not as involved. We've seen the transition from 10 gig to 25. That's one of the reasons why we tested primarily 1080i. We really wanted to do 4K, but we couldn't get there because a lot of the manufacturers are now getting to 25 gig, which allows us to do a heatless 4K flow. It does compound, because on top of that, we saw, originally we're seeing 2 or 3 broadcast controllers. Now we're seeing there's 7 or 8. And originally we saw 2 or 3 SDNs, now we're seeing 5 or 6. So as time goes by, we keep hearing about more and more. And companies that we have a partnership, if you will, are saying, oh, we're now introducing more products that might replace some of the other ones you've been testing.
Yeah, to Alan's point, we've gone through several iterations of the architecture of the lab to test these different things throughout the last 2 years. So what we started with 2 years ago is much different in terms of a network topology, today.
Right.
And I think some of that comes with the evolution of the protocols and the adoption and some of the drop-offs of certain APIs throughout that time as well.
Okay. Anybody else? Well, thank you very much. That was fascinating.
Thank you. Thank
Glad you guys had a chance to present, and
Yeah.
Appreciate it.
Thank
So
you.
that's it for today. We will be posting these videos as soon as we can. Look for them on the VSF YouTube channel. We'll also be posting a link on vsf.tv, and we'll also have a link if you scan your badge at the front door. You will get a link to the presentations on the IP Showcase website when they're ready to go. So feel free. You have lots of information that you can use and download and watch in the future, and go back and forth. So thank you very much, and we start again tomorrow morning at 10 o'clock.